All right, hey everyone, I'm sorry I'm gone today. We are going to continue our notes on linear functions. Yesterday we talked about stepwise functions. They were the ones that kind of look like ladders, like this, steps I mean. We also talked about piecewise functions that have like two pieces. They usually look something kind of sort of like that. Today we're talking about a new type of function. This is an absolute value function. This is going to be more familiar today because you've already actually done this a little, just not the graphing. So we've already talked about absolute value this year, so it's more familiar. We haven't graphed them. This is what the equation looks like. I'll give you a second to write that down. F of x equals straight lines for absolute value. And what you're going to find is that these graphs actually look like a V. Sort of like this. Okay, I'll explain this more in just a minute. We are just ready to learn more about linear equations. This is the last section before we have our review day tomorrow when I'm back, and then we'll have a test over this on Thursday. So, we are going to practice how to graph this and what it's going to look like. Absolute value, if we made a table of x and y values, and if we plugged in -2, -1, 0, 1, and 2 into our equations, I want to see what would happen. So up here in my equation, if I plug in -2, what would I get out? The absolute value of -2 is +2. Well, if I plugged in -1 to my equation right here, the absolute value of -1, absolute value turns anything positive, so this would be 1, +1. If I plug in 0, absolute value of 0 is just 0. If I plug in 1, it's just 1. If I plug in 2, it's just 2. So let's graph these points. Let's see what it looks like. I'm going to have -2. I'm going left 2, up 2. There's a point. -1, 1. -1, 1. 0, 0. 1, 1. Over 1, up 1. Over 2, up 2. Whoa, check that out. It is a V. I didn't lie to you. Essentially what this did, you're not going to be tested on this, but our line y equals x would look like this. This part of the graph right here, if you're writing, you should just look at what I'm doing. This part right here matches this part. It's a slope of 1. We went up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. Has a y-intercept of 0 because there's no plus b. The slope was just 1. But it basically took all these negative numbers and it made them positive. It took this half of the graph right here and it flipped it up so that it's positive instead of negative, because that's what absolute value does. Whoa, brain connections. I hope that this is making sense. So the domain and range, domain of this graph. Domain is talking about x values. Can I plug in anything I want for x? Negatives, decimals, anything? Yes. It's going to be all real numbers. The range, though, we have to think like we did yesterday. I'm going to find this vertex of my graph. That's this part right here, this point right here. We call that point the vertex. And I'm going to draw a horizontal line through my vertex to help illustrate this. Is my graph above or below my pencil? Yeah, it's above it. So I would have y is greater than or equal to, since it was above. And what is that y value at that point right there? 0. All the y values are positive. That's what this says. They're bigger than 0, or they could be equal to 0. So far, so good. Calculator steps. Yes, you can graph these on your calculator. I'm going to show you this one, actually. Here's how you graph it. Whenever you graph, you always push the y equals button. We can clear this out. And then to get to the absolute value, we're going to press math, like we did yesterday. Then you're going to push the right arrow button to get to where it says number. Yesterday we went to int for those step functions. Today, though, we're not talking about step functions. We're talking about absolute value. And I hope you're guessing that this number 1, ABS stands for absolute value. So it's number 1 where it says ABS with a parenthesis. So I'm going to press enter. I got my absolute. Put my X in there. The parentheses represent anything that's inside the absolute value bars. Close them. And then press graph. Bam! That picture right there matches this picture right here. Not too bad. Really not too bad. Okay, so this down here, I thought I wanted to explain these graphs to you like this when I made these notes, but the more I thought about it, the more I was like, I don't know. It's not my favorite way to explain these. I did want to notice last week when we did our 3.6 notes with linear transformations. I'm sorry, it was 3.5. 3.5 notes with linear transformations. I gave you this function. You don't need to write this down. That's the moral of the story. I'm just telling you, I'm making a brain connection here. This is what we did last week in 3.5. This week, the things you learned last week do the same thing this time. Okay, last week we said this plus k could move our graph up or down. The A value makes our graph wider, narrower, or flipped. The H moves it left or right. Okay, this was just for a regular linear function. That's with parentheses. The same thing is true when we have absolute value. Okay, the K moves it up or down. The A makes it wider or narrower. That was like the stretched or compressed with the rubber band. It can also be flipped. This minus H moves it left or right. Okay? So you'll see this as we graph it. I do want to point out, this would be worth writing down, that this type of graph has a vertex. I already told you. The vertex is where the V, the bottom of the V. The vertex in these graphs is the point H, K. Notice how even though it says minus H, this is positive. H, K, that's your vertex. In my first example up here, there was nothing in there, and there was no plus K. So the vertex was the point 0, 0. The domain will always be all real numbers for these types of graphs. And the range is y is greater than or equal to k. Unless A is negative. Then it is y is less than or equal to k. So it's all about the a value because the graph would be flipped over. Okay, that's just a cheat sheet of notes. This will be posted on the website. It already is posted on the website. If you didn't get this written down fast enough, you could ask the sub to pause the video, but you don't probably need to do that. You could get it from somebody else. Alright, we're going to practice some domain and range. To find domain and range, first you put your pencil on the vertex. So here's my first graph. Here's my pencil on the vertex. Then you ask yourself, what is the y-coordinate? This is the point 1, comma, 1, 2, 3, 4, negative 4. So the y-coordinate is negative 4. And then you ask, is the graph above or below my pencil? So here's my pencil. The graph is above. So the range is y. Since it's above would be greater than or equal to. Below would be less than or equal to. Is greater than or equal to negative 4. The domain is always all real numbers. You can plug in anything you want for x, but x is always going to be greater than. Okay, let's try another one. You guys are probably doing awesome. I don't know, I'm not there, but I'm guessing you are. Domain is always all real numbers, so you can plug in anything you want. The range, think about it. Putting your pencil on this point. It's the point 1, comma, 0. Range is talking about y values. Y is, let's decide. Is my graph above or below my pencil? Above. Above means greater than. Greater than or equal to. The y value is, in this spot, 0. Alright, let's try another one. Domain is all real numbers. The range is the point negative 2, up 3. Put my pencil right here on my vertex, and is my graph above or below it? Well, it's below it. So this time I'm going to write a less than sign. Y is less than or equal to. My y-coordinate was 3. Okay? That was just some practice to help you feel real confident like you got it. Alright, let's try a couple of these together. On your homework, you're going to be asked to graph, state the domain and range, and then state how it relates to the parent function. So something I only explained in one of the hours. If you're in second hour, I did not explain this last week. If you have x minus 1 inside of here, it's actually, so if you have x minus h in our linear equation, this is worth writing down. This part right here, x minus h moves the graph right. I know it's opposite of what you'd expect, even though it's a minus. It moves it right. If you had x plus h, it moves the graph left. So I could graph this by typing in math, number, absolute value, x minus 1. I graph it. Bam! It moved my vertex right one spot. So all I need to do to graph this is put my vertex right here, go over, There's my graph. What's the domain? All real numbers. Range, we got to think about. We'll put our pencil on the vertex. It's the point 1, 0. Range is talking about y. Is my graph above or below my pen? I hope you're thinking above. Maybe you even said it. I hope you did. Above my pen. So it's greater than or equal to, and then I got to plug in the y value. The other thing I'll point out here is the y value is 0. So that's the number that's going in here. The number that goes in here will always be whatever your k is. This one doesn't have a k, so it's just going to be 0 that goes in. How it relates to the parent? Well, it moved right 1. That's all you have to say. Right 1. This video will be posted on the website in case you want to look back at it. Let's try another example. This time it's going to be x plus 2. If I was there, I'd make you turn to your partner and say, what do you predict this graph is going to look like? But I won't make you do that. I hope you're thinking it though. If it's a plus 2 and I have x plus h, that's going to move us left 2 units. But let's check it on the calculator. Here's a trick. You can just type over it. If you put your little blinking cursor on the minus, I'm just going to put plus 2 over top of it and hit graph. And man, look at that! It moved it left 2 times, 2 spaces. Right here's the vertex. So I'm going to move left 2. Here's my new vertex. And it still has a slope of 1 and a slope of 1. There it is. Domain is all real numbers. Range is talking about y. I hope you're seeing it now. The graph is above the vertex. Y is greater than or equal to. What's the y value here? This is the point -2, 0 at my vertex. The y value is 0. So it's greater than or equal to 0. How it relates to the parent, it moved left 2. Number 3. Ooh, this one looks different. See how this had a number inside the absolute value? This has a number outside the absolute value. So my domain, well, let's graph it first. I hope you're thinking about what this would look like. To change my graph here, I'm going to delete. So it's just x. You need to close those parentheses. X, close parenthesis, -4. Graph. Whoa, is that what you expected? What happened to this graph? It moved 1, 2, 3, 4 down. It went down 4, 1, 2, 3, 4. Domain is all real numbers. Range is y is greater than or equal to, well, the point right here is the point 0, -4. My y value is -4. How does it relate to the parent? It moved down 4, which makes sense. This -4 is outside the little absolute value, just like k moves the graph up or down. We have a -4, so of course it should go down. Whoa. You guys are doing great. A couple more here. Let's try this one. -3 on the outside. I'm going to have to clear this out. -3 math number absolute value x. graph. Whoa. This is our first one that looks like this. It's flipped over, and it got taller. Oh, no, it actually didn't. Sorry, it's just flipped over. Well, actually, it did get a little taller. Okay, a sketch for these graphs is fine. When I plug in, actually, I'm going to be a little more precise. If I plug in -1, it's going to be negative, it'd be 1 times -3, which is 3. 2, 3. There's going to be a point right here and a point right there. Domain is all real numbers. The range this time, y is, here's my pen, my graph above or below. It's below. So this time I'm going to write 8 less than or equal to. My vertex point is the point 0, 0. So the y value is going to come down here. How it relates to the parent, there's two things that happened here. It reflected or flipped, since we knew it was a negative. And the 3 makes it narrower, which we say it was stretched. Remember the rubber band? If you can imagine stretching it, makes it skinnier, narrower. Number 5. Ooh, let's see what happens when the -3 is on the inside. Whoa! It's narrower still, but this time it's flipped up because that absolute value bar is going to make our answers positive. 1, 2, 3, 1, 2, 3. The domain, it's all real numbers. The range, y is greater than or equal to, this is still the point 0, 0. How it relates to the parent, it did not flip. It just got stretched. Last one. This one has a -1 on the inside and a +3. I wish I could make you turn and talk to your partners to predict what would happen. There's 2 things that will happen this time. Think them in your head. X minus 1 plus 3. Let's graph it. I hope you're at least thinking 2 things right now. Is it going to move left or right or up or down? It moved right 1, up 3. -1 tells us right, the opposite of what you think. 3 tells us up. So it went right 1, up 3. And looks just like this. Domain is all real numbers. My vertex point, sometimes the homework questions will ask you for the vertex. You guys can find that. Over 1, up 3. So my range is y. Put my pen here. My graph is above that spot, so it's going to be greater than or equal to 3. How it relates to the parent, it went right 1, up 3. Wow, that was really a lot of brain power there. Okay, I just want to do a quick recap. You have not seen these graphs before, but you have done absolute value. What we did today was take what we learned from 3.5. It might help you during the homework if you want to pull out those notes. We remembered that A tells us if it's wider, narrower, or flipped. H tells us left or right. K tells us up or down. We talked about domain and range and how to find it. You put your pencil on the vertex, and you can even just lay it on the vertex. You ask yourself, what is the y-coordinate of the vertex? That's your magic number. That's what will always go here in that spot. And then you ask, is the graph above or below your pencil? That tells you if it's above, you're going to have a greater than. If it's below, you're going to have a less than. All you really got to do is some stuff like this. So here's your homework problems. You got plenty of time. Probably, I mean, man, by the time you got class started, you turned in your homework from yesterday. You will turn in this homework as well. You can just turn it all into the sub and they will binder clip it together for me. These are your homework problems. And you are all set.